Hey guys, welcome back to a new video. In the previous video, we looked into the electron affinity, and previously we looked into the ionization potential. We're just looking into the characteristics of atoms, and in today's we're looking into the one of the main base of chemistry, that is the electronegativity. That is kind of a important topic, and I would write the definition first of all from the books. Then we'll be clearing the concepts on the basis of examples and all that. So I would take a minute for writing definition. Okay, so here is a kind of simple definition. Uh, what is electronegativity? Electronegativity, first of all, is a power. The electronegativity is a power. Is sort of power. What sort of power? Which which the object which is holding this power is an atom. The power of an atom. The electronegativity is first of all the power of an atom. What sort of power in an atom? It is the power of an atom to attract. This is the attracting power of an atom. What sort of attracting? Attracting the shared pair of electron. What does the shared pair of electron mean? Like shared pair of electron toward itself. Like electron negativity is the power of an atom to attract what attack to attack some sort of electrons toward itself, to attack shared pair of electrons toward itself. You will be not understanding it until we have an example. But let me tell you a concept like this one. Electronegativity. Electronegativity is inversely proportional to number of shells. Do remember this point. This is kind of very important. Number of shells. As much number of cells, as much the less electronegativity. To understand my beautiful writing, that's your task. I wrote in electronegativity is inversely proportional to number of shells, right? So we'll be taking example like different atoms have got different electronegativities, and we have got a scale for that. Uh, there's some sort of attraction. We have got hydrogen atom, and hydrogen has got 2.1 electronegativity. Uh, we have got electronegativity table, and these are determined experimentally, and you need to remind them. Chlorine, you've got 3 electronegativity. 3 electronegativity. Now what will happen is that uh, the one which is having more electronegativity will attract the other pair. The chlorine will attract the shared pair of hydrogen toward itself. This hydrogen would be attracted because it is having less electronegativity, and chlorine is having 7 pair of electrons in its last shell, and it is having 1, and that would go over here. The one will go over here, and the RPET will be fulfilled. Now this is a complete game. Uh, it has got 7 electrons. It is more powerful. It has got more electronegativity, that is 3, and the hydrogen gets attracted. And the result, what happens is uh, HCl forms. But the hydrogen is attracted toward it. That means some portion of the hydrogen is being shared with the chlorine. Uh, so chlorine will get negative charge because it has taken some sort of portion of hydrogen, while H is positive. This is the reason we have got polarity in these sort of molecules. And do remember one point, that is this is partial positive and partial negative. Like this keeps disturbing a lot. This is not permanent. This is temporary. The bonds make and break. That is not a permanent bond. This is just found by sharing, and that is not any sort of proper electron bond that is based upon the chemicals or the electron sharing. That is just a bomb that the bond which is formed accidentally while the HCl formation, and due to the electronegativity difference. Like here, if you see, uh, we have got we can find electronegativity difference. Like we have got 3 over here and 2.1 over here. The electronegativity difference is 0.9, right? 0.9. So this is 0.9 is the electronegativity difference, and the one which are having more electronegativity difference, they are more stronger bonds. They are having more strong bonds. and we have got a table in which you're looking into how are we arranged. Like over here we have got uh, this line, and here we've got 1.7. 1.7. Okay, so yes, electronegativity is kind of when the let me make the table first, then I will making you some sort of great things. I will telling you the great tricks to deal with it. 1.5, 1. 8, 2, and so on. Here we've got 1.7. Here we've got 1.8. Sorry, here we have got uh, you can say uh, we have done a mistake over there, but will be overcoming that. Like here we have got this one, this one. Okay, so yes, 1.5, 1.3, and 1.2. It goes up and down. Here we have got 1.9, 2.1, and 2.3, and so on both sides. Now what's happening? Uh, what happens is this: if the electronegativity difference is increased in this part, then an ionic bond is formed. Ionic bond is formed, and there would be no concept of electronegativity in them because the electron is completely transferred. We have discussed is that when an ionic bond is formed, the electron is completely transferred. Then there is no any partial sharing. That would be not partial positive, partial negative. That would be permanent positive, permanent negative. So that is the thing. While if we talk about here, we have got electronegativities from this sort of point. We will get covalent bonds with electronegativities. Covalent. Sorry. Covalent. Whatever it is. So this is, I do hope that you got the trick. Like uh, electronegativity is much more than would be the hydrogen. If the chlorine and hydrogen are having more electronegativity difference, like for suppose they instead of 0.9 they had a 2.1, so that would be a ionic bond, that would be permanent H positive Cl negative. But we have got a electronegativity difference of 0.9, so that comes in this covalent category, and that would be a partial positive, partial negative charge. So I do have learned something, and if you did do like the video, meet you guys in the next video. Till that, goodbye.